Welcome to the Arkansas Food Farms and Forests podcast, the podcast bringing you the latest on food, fiber, and forestry research from the Arkansas Agricultural Experiment Station, the research arm of the University of Arkansas System Division of Agriculture.
Welcome to Food, Farms, and Forests. I'm Jennifer Fouch. Today we are learning about the research related to the project Restoring Bottomland Hardwood Forests, which aims to plant about 600 acres of bottomland hardwood oak forests in Arkansas in the next 3 to 5 years. Joining us is Dr. Tian, a researcher for the Arkansas Agricultural Experiment Station and an associate professor at the University of Arkansas at Monticello. Dr. Tian, thanks for being here with us.
I'm glad to be here. Thank you.
So last time here on Food, Farms, and Forests, we talked about this project, its goals, the history that led to it being needed with Dr. Michael Blazier, who is the Dean at the College of Forestry, Agriculture, and Natural Resources. And today we are diving into the research with Dr. Tian, who is the principal investigator and the lead on this project. So, Dr. Tian, the Restoring Bottomland Hardwood Forests project aims to accomplish three main things: plant 500 to 600 acres of oak forests by recruiting 10 or more small underserved landowners, quantify the ecological and economic benefits of hardwood plantations in terms of timber and carbon, and then help landowners manage the land and market these commodities. That's a big project. It sounds ambitious and it sounds really cool. Let's start by focusing on your research specifically and how it contributes to this project, because we hear these big goals, but there's a lot of scientific research and data and measuring that goes on behind the scenes. Can you explain what your research is and how it's contributing to these goals?
For sure. So basically, from my perspective, I just focus on evaluating the ecological as well as economic benefits that were provided by implementing the restoration practices on those lands. This type of wetland actually provided many important ecosystem services, such as timber products, very important habitat for many wildlife, water regulation, as well as carbon sequestration. So, speaking of those ecosystem services, some of them are, monetary services, we call it, because there is a market price, for example, for the timber products. But there are also some non-monetary ecosystem services, such as carbon sequestration, such as water regulation. And how can we put a dollar value on those benefits? So that's what my research really just contributed to this project. Think about this: putting a dollar value on those non-monetary services actually can help the landowners, to know how much kind of benefits they really provided from restoring this type of forest land. And also it can help those small landowners, underserved landowners, to improve their economic status, because, one important objective for this project is also focusing on marketing those, we call them climate smart commodities. So that's my research part. Mm-hmm.
So how do you do that? How do you measure, especially as you mentioned, the economics might be a little bit easier to measure because we can talk about the price and the cost of timber and the market and all of that. But how do we measure the carbon sequestration, the water quality, as you mentioned?
That's really a good question, actually. So, from the economic part, actually, we do have some different theories or methods to measure. So, for example, one typical method is called, willingness to pay. Basically, we just conduct some surveys and try to, using the surveys, that's a quantitative kind of data collection way. And after that, we will just, using some data analysis method try to estimate or put a dollar value on those non-monetary ecosystem services. They are already very commonly used in this regard. So generally speaking, we just, have those kind of methods already.
And then how do you measure the the economic side of it with the timber cost and things like that?
So basically, planting, for example, for the Petri Research Station, the demonstration site, that's a 40-acre site. So when we plant them, we will have the seedling part. So we know how much it cost to buy the seedling, right? And we know the transportation costs, and all the costs, we will know, we will record them. So that's the costs part. And then for the economic part, 10 years, 15 years, 20 years later, we can estimate what's the biomass growth. And then, we have the market price, right? There are a lot of different sources to record the market price for different timber products. So that's just kind of the logical way how to get the economic benefits from the different timber products.
I know you recently had a visit to one of the sites where some of the trees will be planted. This will be the Pine Tree Research Station, where some planting will begin this fall, I believe, is what Dr. Blazer told me. How did that visit go? What does a site visit look like at this stage of the project, and when will planting begin, and what's that process like?
So from there, we have a 40-acre site to plant. And according to our plan, actually, we will plant that site starting October next month. So on that site, we have two different planting methods. One is called potted planting versus bare root planting. So basically, the 40-acre, half of them, basically 20 acres, will be planted using bare root. And then another 20 acre will be container or potted planting. And the major reason for using those two different planting methods, that's still try to answer another research question. So basically just try to say what's the ecological as well as the economic trade-off between the different planting methods, including, later, what's the growth difference from the different planting methods. So technically, we call it site preparation activities. So such as spraying, mulching, and also subsoil. So that's basically the three major site preparation works we will do for that site. Right now, we already finished spraying them, and the next step will be mowing. And after mowing, so basically subsoil and planting, we just try to figure out all the details about, the planting activity as well as the site preparation activity.
Okay, very cool. So planting to start in October this fall. When will be the next site visit, and what will you be looking for?
So basically, for this site, we will do the site visit, at least a few times a year. Because like what I mentioned, we do want to answer the research question. So we need to measure the tree growth or even the survival rate, next year for at least two times. Just try to collect the data to answer what's really the ecological difference between the two different planting methods. So, and also, for that site, we will use it as a demonstration site for our future, outreach kind of activities. We will show it to landowners. So I think, with that being said, that site will be monitored at least 2 or 3 times a year. So
what types of trees are being planted? Is it just oak trees, or are there specific types of oak trees, and why oak?
Red oaks basically is the major focus for our project. And there are different reasons for focusing on red oaks because, it is the most important tree species for the bottomland hardwood forests. And from the wildlife perspective, red oaks actually provided the major food for waterfowl. Then from the timber products perspective, red oaks can produce very high quality timber products in the future. So that's basically the major reasons why we wanted to focus on red oaks. we will plant a combination of different kinds of red oak species. Just try to train the major species grow well in this system. So it's a combination of the red oak species, persimmon, black gum, sycamore, white oak, oak calm oak, as well as nut oak. That's the major species we will plant on this site. Black gum or persimmon, actually we treated them as the training species to train the red oaks grow well in the future. So just increase their computation.
Okay, that's interesting. That's interesting. And then you said you'll be doing site visits a few times a year. What is success going to look like once you step on a site? What do you want to see to say, yes, this is working?
That's a good one. So basically, this year we will plant some of them, and then starting next year, yes, we will measure the growth rate. Just how fast they grow, how well they grow, basically refers to the survival rate. So yesterday I talked with one of our team member, and I asked what's the normal kind of survival rate for red oaks. And my guess is 80%, but he mentioned that 90% at least. So it's a good condition for the survival rate. So next year obviously we will check on it to see what's the survival rate after planting, and also the growth rate. And not only next year, in the future, how many years, because that site, even though our project length is about 7 years, but for that site, we will keep there, and we will not harvest it probably until 20, 30 years later, until it becomes some marketable kind of timber products. So with that being said, we will have a really good record for the growth rate, between the two different planting methods. Again, for the further kind of future, with that kind of data, that will just make the research very solid.
And there are 6 other researchers on this project that you are overseeing. Each of them are focusing on different aspects of this long-term project. You mentioned water quality is one of them, and there are many other aspects. Can you talk about the other researchers and their research and the different aspects they're looking at and how it's going to contribute to this project?
Sure. So for this project, we have 2 different collaboration organizations. So the first one is the University of Arkansas and Bluff. So they have a program called Keep It in the Family program. So those folks there will help us to connect with the small landowners or underserved landowners. And another collaboration university is called Texas A&M University. So the researcher from there is Dr. Jianbang Gan, actually. So he has a lot of experiences in the carbon credit system establishment. So carbon is a very important topic in this project. So including the carbon quantification, carbon, economic benefits of carbon, as well as how to establish the carbon credit system. So that's a system we will try to establish from this project. So he has a lot of expertise in that regard. And then other researchers from the UAM, for example, Dr. Pelkey, he is a forest economist, and he basically just work on the ecological benefits, try to estimate the non-monetary kind of value from the services. And then, Dr. Doug Osborne, he is a wildlife professor, so he will focus on, we know this type of forest land actually provide a very important habitat for the waterfowl. So we know waterfowl hunting actually is a very important, activity culturally, economically in Arkansas. So his research basically just try to say how, this unique wetland type contribute to the waterfowl population. So that's basically his research. And then, we have a soil scientist. Her name is Katie Dake. Actually, she is working on the carbon quantification from soil, because soil actually is also a very important part for the carbon for the carbon benefits. So that's why she is working on quantifying, what's the difference between different land yields for the soil carbon. So that's his part. And we do have another researcher, actually, his name is Jacob Hackman from, the UA extension position. So he basically just, focusing on, all working with me together just on the extension or education part. So that's basically kind of the last objective of this project.
Also, I want to mention before we go that this restoration project is supported by a $3.71 million grant from the United States Department of Agriculture, and this is through the Partnerships for Climate Smart Commodities program. Dr. Tian, one last question for you before we go. What was that like for you to see that this grant was coming to UAM and for you to be the lead on this huge project that is going to have benefits for decades and decades to come?
Well, when I see, the announcement from the USDA, the first kind of feeling is just like, wow, incredible. And so excited, just really, such a big grant can bring it to the UAM, to Arkansas. That's really, really my honor. That's, as a researcher, that's what I want to do. But at the same time, I just feel like, wow, the pressure. How should I do this? But later I just realized I have a team here, not just myself, right? I have a very good team with different expertise on different aspects. So then I just, when I talk with the team members, they are all just feel so excited and just, no worry, we will work this out. So it's a very exciting project. And, we do hope that through this project, we can just, attract more landowners to participate.
Very cool. Yes, I'm sure it's been a lot of paperwork, a lot of research, and now you're actually putting the seeds in the ground and seeing where it goes. Those are all of the questions I have for you. Is there anything else you want to talk a little bit more in detail about the research that I didn't ask?
I think, for this project, it's we call it an integrated project. So we do have extension component and also, the research part. So basically, the three major research objective is just like what you mentioned: evaluate the ecological, economic benefits for the climate smart practice or restoring the bottomland hardwood forests. And another thing is just try to quantify the climate smart commodities, just like the ecosystem services I just mentioned, the monetary versus non-monetary. And another thing I kind of wanted to highlight, for this project is, marketing the climate smart commodity is another important objective. So, the marketing, we will develop some, key marketing kind of strategy, how to help the small landowners or underserved landowners to market the different kinds of ecosystem services. So marketing them actually, can help those landowners either to improve the economic status or help them to retain the working land right now.
Well, Dr. Tian, thank you so much for your time and sharing your expertise with us.
Thank you.
That was Dr. Nana Tian, a researcher for the Arkansas Agricultural Experiment Station and an associate professor at the University of Arkansas at Monticello, and principal investigator on the Restoring Bottomland Hardwood Forests project.
The Arkansas Food Farms and Forests podcast is produced by the Arkansas Agricultural Experiment Station, the research arm of the University of Arkansas System Division of Agriculture. Visit aaes.uada.edu for more information.